Okay, so hello, good day. So today we are looking at the other aspect of calculus, which is integration. So the integration is the anti-differentiation, which means it is the inverse of differentiation, which means if we have a function, we differentiate it, we get another function, then we can get the original function back by integration. Okay, so if for instance we have y is equals to x cubed and we differentiate this function. What do we do? The y ds from here is going to be 3 times 1, that will be 3. Then x, then minus 1 from here, that will be 3 minus 1. Right? That is what we do. And we'll get 3x squared. Okay? That's what we do to get this. Now, if we want to get that function back, then what do? We say, let's say this one is g of x. For instance, I'll call it g of x. Okay, call it 3x squared. Now this 3x squared. Now, what do we do to get this particular expression back? The first thing we'll do is we'll add 1 to this to the power. That will be 3x is about 2 plus 1. Right? Then we also divide this by that power. Then 2 plus 1. Okay, that's what we'll do, right? So at that point in time, this is going to be 3x raised to power 3 all over 3. And when this cos this, that will be x raised to power 3. So g of x is this. So this is what we call the integration of this differentiation, that is the integration of that function, right? To get the function back. So and that is what we call integration, okay? Like so, that is the y dx, for instance, is now 3x squared. So a better way to now represent this to get y back is that we take this dx, we'll put it here. So it will be dy will be equal to 3x squared dx. Right? Now this d that is here, we should now go and come to this side and be represented as a summation sign. It will be represented like this. Right? So that means this y will now become integral 3x squared dx. Right? Integral 3x squared dx. So this is how we represent integration. Okay? Now this integration, how we do it is, we do what? We add 1 to the power. We now divide it by the power, the new power. So that will be 2 plus 1 over 2 plus 1. Okay, so this is now going to be what? Integral. Okay, whenever the moment we introduce this power, addition of power, we don't need to put this anymore because it means we have carried out the integration. So this is not supposed to be here. Okay, so this is going to be 3x raised to the power 3 over 3. So and that's going to be x raised to the power 3. So we have gotten back the original function, which is y. Okay, so this is what we call the integration of a differentiation, right? Okay, so integration and differentiation, they are inverse of each other. So in other words, whenever we have the y dx to be equal to ax raised to power n, then y is going to be the integration of ax raised to power n dx, and that will be what? Ax raised to power n plus 1 all over n plus 1. So this is the general expression, and this expression can be extended for more than one term. Okay, now there is something else we also need to take note of. Another thing we should take note of is if this one has a constant attached to it. If for instance now we have the y dx, we have y to be equal to x cubed plus 4, for instance. Okay, what is going to happen if we differentiate this? What are we going to get? The y dx from here is going to be what? 3x squared, right? And differentiation of a constant is going to be equal to 0, right? So we are going to be having 3x squared as our dy dx. Now, if we want to guess back our function, what do we do? The way we do here, we say let this one come here, and d will become the integral sign. Y will now become integral 3x squared, right? dx. Okay? And if we apply this formula here, this is going to be 3x raised to power 3 all over 3. 3 will cut 3. And what are we going to get? We are going to get s cubed. But we are missing something. We have seen from here that we have not gotten back our initial function. That is why in integration, whenever we are carrying out integration, we normally add this plus c to it. Anytime we carry out integration, we add plus c to it, because eventually in some situation, that c can represent a constant. This constant that was omitted in the differentiation. So that is why we need to always put plus c in that regard. So whenever we carry out our differentiation, we usually put plus c into our integration, okay? So that if we are given additional information, then we can get that c back, right? So, and that is how we usually need to put c into our integration, okay? Thank you. Please like, subscribe, and share.